What have you learned about differentiation?
dy dx.
Okay, good. All right. Learn about dy dx. Okay, what else?
Marginal profit.
Okay. The marginal profit and all these things. Okay, so marginal. Only marginal profit. All right, we have marginal cost. Then revenue and marginal profit. Yes. Okay. Right. Now for differentiation, we actually learn about 7 differentiation rules. Okay, differentiation rules. Now, including the chain rule, the product rule, and the
quotient rule.
Quotient rule. Okay. Yes. All right. So we learn about marginal cost, marginal profit, and all these things. And okay. And what else? The last part we learn about finding the
maximum and minimum value.
Okay, good. Maximum and a minimum points. Okay, so for maximum and minimum points, we actually learn 2 methods. All right, what are the methods? Start with the first.
First derivative.
Okay, first derivative test, right? First derivative test. And second derivative test. Okay, so these are very important topics in differentiations. Okay, so make sure that you revise, right, and remember this. Okay, now finding the maximum and the minimum point, this is part of the optimization method. Okay, optimization is actually one of the important concepts in when you work outside later. Okay, so we want to find, let's say for example, you want to know how to find the maximum profit, right? Find the quantity, right, to get the maximum profit, or you try to find the quantity to get the minimum cost. Okay, or even you want to, for example, you want to build the fence. Okay, you want to know the maximum area. All right, you want to fence the maximum area. All these, they are actually under optimization. Okay, so for more information, you can actually refer to the books. Okay. Now, today we are going to learn about a concept called integration. Okay, so what is integrations? We are going to take about 1 to 2 weeks to learn about this. Okay. Now, so the objective for today, all right, or for this section is, first we are going to learn the rules of integration. All right, and after that, we are going to learn there are 2 types basically of integration, and they are indefinite integration and the definite integration. Right, we have 2 types of integration, so we are going to learn what are they. Okay, right, now after that, we are going to learn about the integration by substitution. This is the integration technique. All right, integration by substitution. This is more advanced technique to integrate. And finally, we are going to apply the concept to the function and the graph. Okay, so basically today we are going to, maybe we will cover until here. All right, so then the rest we are going to do it next week. Okay, now, so what is integration? Integration is also called antiderivative. All right, now often hear, sometimes we say differentiation, right? Sometimes we hear derivative. Okay, can you tell me what is the difference? What are the difference between these two? What's the difference? Differentiation and derivative. Any different? Or no different?
No different.
Okay, no different. Okay, partially correct. Actually, they are slight different, small different, but basically they are the same concept. Now, let me explain. Okay, now when we have, for example, x squared, okay, x squared. Now, when we differentiate, now I use the word differentiate. When we differentiate, we get, what do we get?
2x.
Okay, good. Thank you. 2x. Now, this process is called differentiation. The process, the action, right? When you perform the operation, the operation is called differentiation, where we bring the 2 down and the power minus 1. Okay, now what is derivative? This is called derivative. Okay, so derivative refer to this one. Okay, so the derivative actually is a noun for the product we get. This one. This is called derivative. The process is called differentiation. Is that okay? Okay, now, so we are going to learn about antiderivative today. Okay, before I proceed, students, I think there are surrounding some coming in. Can you check your mic? Okay, right. Thank you. Now, antiderivative, you know the word anti means that. What is the word? What's the meaning of anti? It means that it's something like a reverse, right? Okay, so antiderivative, it means that it's the reverse of derivative. So now the reverse of derivative is called the integration. Okay, so now when you hear the word integration, this refers to the process. Okay, the process is called integration. And the answer we get, this one, is called antiderivative. Okay, so the differentiation and the integration, they are the process, they are the operation, right? Where the derivative and the antiderivative, they refer to the answer we get. Okay, is that clear to you, students? Is that okay?
Yes.
Okay, right. Thank you very much. Okay, so definition. Now, if f prime x equals to fx, then f is an antiderivative of f. Okay, so what does that mean? It means that, okay, we have fx. After we differentiate, we get f prime x. Okay, so, oh, okay, sorry. Wrong one. We have fx, capital F. After we differentiate, we get f prime f, capital. Okay, so this one, okay, is fx. Let's say we get this one of fx. Then the antiderivative, right, refer to the reverse process. The reverse process of the derivative, right, is actually fx. Right, f is an antiderivative of f. Okay, so now the example here, we have the x squared. All right, after we differentiate, we get 2x here. All right, now, so when we integrate this one, the antiderivative is actually x squared. Okay, so this slide here, all right, actually just want to show us that the antiderivative is actually the reverse process of derivative. Okay, so the integration is the reverse process of differentiation. All right, so this is the conclusion for this slide. Any question? Okay, if no questions, then we move on to the second one. All right, now how do we actually symbolize the antiderivative? So this is the symbol we use. Okay, so we use this one. This one is the sign of integral, right? Integral sign means that the integration, but when we want to perform integration, we actually use this sign. This is called the integrand. So it refers to the function that we want to integrate. This one refers to the variable that we want to integrate. So we want to integrate on x. Okay, and the answer we get here is called the antiderivative, and the c is a constant. I will explain about the c later. Okay, so this you need to remember the sign, how to write the sign. Okay, so please remember this, how to write this, because in the final exam, I always see students, they give me all kind of a different type of writing. Okay, so please remember how to write this. So usually we write the sign of integration first. All right, then followed by the function, and the dx here tell us that we want to integrate on the x. So if you want to integrate on y, so it will be dy. If you want to integrate on the u, then it will be du. Okay, so it refers to the variable we want to integrate. All right, then equals to, write the answer plus the constant. Okay, so as I mentioned earlier, I will explain the constant later. Okay, now this part, when we integrate like this without number, we call that indefinite integration. If we integrate with number, right, let's say 1 to 2 or 3 to 4, this is called definite integration. All right, and the answer we get, right, they are actually the area under the curve. So we are going to talk about the detail of this later when we talk about the application. All right, but however, in this slide, you need to know that, okay, so when we have a number here, this is called definite integration. Without number, it's called indefinite integration. Okay. Okay, let's see the first rule. The first rule, the indefinite integration of a constant. Now, when we integrate a constant, it becomes kx plus c. Now, what does that mean? Let's start with the differentiation first. Now, if I have the y equals to 2x, okay, when we differentiate, what do we get?
2.
2. Good. All right, when we differentiate, we get 2. All right, so when we have 2x, we differentiate. I put a dy dx here. When we differentiate, we get 2. So when we integrate, 2. So we are going to get back the x, right? So we have 2x. Okay. Now, so when we integrate a constant, a number, you need to add x for it. Okay, so this is the rule number 1. When we integrate a number, all right, we actually put the x behind it. Okay, now any questions here? Any question here? No, huh? All right. If you know questions, then I want to ask you, what is the c? Why we need to add c here? Okay, why we need to get 2x plus c? What is this about? Any idea?
The intercept.
The intercept, correct, right? It's correct. It's the intercept. All right, but then why can't we just write any number for the intercept? Okay, now I'm going to explain it in the following discussion. I'm going to explain why we need to put a c. Okay, now let's see the few function here. Now, if I have y1, I differentiate, I get 2, right? If I have y2, 2x plus 5, after I differentiate, what do I get? Okay, student, differentiate 2. This one. What do I get? I still get 2, right? Okay, so what if I have y3, I have 2x minus 10. When I differentiate, what do I get? Still 2, right? Okay. Now, it means that when we differentiate, the constant here disappeared. Okay, 5 after differentiate disappeared. 10, negative 10 after differentiate, it disappeared. So when we do the reverse, when we integrate, we do the reverse, there should be a constant here. Okay, there should be a constant here. But however, can we know what is the value of the constant? Do we know the constant, whether it's negative 10 or 5 or 0? We don't know. We don't know what is the constant. All right, so we don't know. Therefore, we just put the c here to represent there is a constant. This constant can be any number. It can be 5. It can be negative 10. It can be 0, or it can be anything else. All right, but we don't know what is it. Therefore, we just put plus c. Okay, so I hope I explained why we need to put a c here. There's this because we have a constant behind, but we don't know what is the number. Okay, so the same thing goes to this one. So when we integrate 10, a number, so we add x to it, it becomes 10x plus c. Okay, any questions here? Okay, good. All right, no questions means that right, we can proceed. So rule number 1, when we integrate a constant, a number, we add x to it. Right. Now, number 2 is called the power rule for integration. All right, so again, this is the reverse of differentiation. Okay, so now if we integrate x to the power of n, so what do? First, we add 1 to the power. All right, the n add 1, right? We add 1 to the power. And after that, we take the whole number, all right? This n plus 1, we divide. All right, the x to the power of n plus 1 divided by n plus 1. This number we bring down to divide. All right, and we plus the c to represent the constant. Okay, now let me explain why we have this thing. Now, when we differentiate, let's start with x. Okay, let's start with I use m. So when we differentiate, okay, what do? Do some revision. First, we bring down the m, right? Okay, so first step, we multiply m. Okay. Now, after that, second step, what do we do? Second step?
Power minus 1.
Yeah, good. Power minus 1. So the power minus 1. Okay. So we multiply the power, then the power minus 1. Okay, now when we do the integration, it's supposed to be the reverse. Okay, so I integrate this one, mx, m minus 1, and I integrate this one. Okay. Now we are going to do the reverse. Okay, student, see here. Now look at the screen here. Now when we do the reverse, we are doing like this. All right, we are doing from bottom to top. Okay, we're doing from bottom to top. We are doing the reverse one. Okay, now what happened is when we have, okay, this one power minus 1. Okay, power minus 1. The reverse will be power plus 1, right? Okay, power plus 1. So I have the mx here, then I have the power plus 1. Okay, so it's the reverse, but we start with number 2. We do the reverse way. Okay, so the sequence we have to reverse, the action we have to reverse. So the power will plus 1, all right, to indicate the reverse of power minus 1. Now after that, right, step 1 here, we multiply the power, right? So the reverse will be we divide the power. So the new power here is m, right? So we divide it by m. Okay, plus the c, and from here you can see after we cancel the m, it becomes the x. This one, negative 1 plus 1, it becomes 0. So we have xm plus c. So x to the power of m plus c. So we get back the, all right, the y. Right. So this one is called the antiderivative. Okay. Any questions here? Any questions here? Okay. So remember, first we add 1 to the power, then we take the new value of the power, we divide. Okay. Right, now let's see one of the example here. Right, we integrate x squared. So first the power plus 1. All right, so then we have 3, right? So divided by 3, then plus c. So we get this. Okay, any question before we proceed? Okay, so rule number 3. Now, if we have a number in front of the x, right, just like this, a number in front of the x, when we integrate, what do we do? Okay, good news, just like the differentiation, we just put aside. Okay, we just put it aside. All right, do nothing, all right, for the integration. But later we are going to multiply it. Okay, so we just put aside, we integrate the x only. All right, so for these questions here, we put the 3 aside. All right, 2 plus 1, 3, and divided by 3. All right, plus c. after that, the 3 here we can actually eliminate. So we have x to the power of 3 plus c. Okay. Now rule number 4, all right, is called the sum or the difference rule. Now it says that when we have two function of x, this one is something something x, like this, plus or minus something something x, right? Another function like this. So when we integrate them separately. Okay, so just like this one. So we have one function, this is fx. We have another function, this is gx. So when we integrate, what do? We actually integrate them separately. So integrate this one, power plus 1, then divided by the new power. And for this one, we just add the x to it. All right, now after that, we plus c. Now actually we need to plus c here. All right, so we have to add the plus c here. Okay, after we integrate, we simplify. We have x to the power of 3 here, plus 2x plus c. Okay, so rule number 4, when we integrate two or more different functions, we integrate them one by one. Okay, any question? Okay, so we have 2 examples here, then followed by 6 exercises that you need to complete in the class. All right, so today we don't have a class participation activity, all right, because I want you to complete this one in the class. Okay, so now find the antiderivative of this. Okay, so now to integrate this one, okay, what should we do? First, we need to change this one to indices just as usual. Okay, what happened to the z to the power of 5? When we bring up, it becomes
-5.
Okay, all right, thank you, -5. Now, take note now, because we are actually integrate on the variable z, so I have to put here dz. Okay, so integrate 12 z to the power of -5 dz. All right. Okay, next, the 12 is the number, so we can just put it aside. We integrate the z only. Okay, so integrate the z. So when we integrate the power plus 1 and -5 plus 1, we get -4, right? So divided by -4. Okay, so plus c. And after that, we simplify here 12 and -4. Simplified, we get -3. So we have -3 z to the power of -4 plus c. All right, and you can leave your answer like this, or you can change it back to the denominator, z to the power of 4. Okay, so any questions? Okay, example B. Now we have x squared plus 1 over square root of x, and we need to integrate this. Okay, now how to integrate this one? First, we need to change the square root to the power of 1 over 2. Okay, so again, we need to change to exponential form or index form, indices form, so that we can simplify and integrate. Okay, now after that, we split this into 2. since this is the denominator, we can actually split it. So we split this into 2. And what happened here? Divide, right? So divide, we can actually change to minus. So we have 2 minus 1 over 2. And this one, of course, we bring the x up. It becomes negative 1 over 2, the power. So after that, we are going to integrate from here. All right, so this one, what do we get? 2 minus 1 over 2. Okay, student, 2 minus 1 over 2, what do we get? We get 3 over 2, right? All right, 3 over 2, so plus 1. All right, so we get 5 over 2. Okay, so 5 over 2, after that we divided by 5 over 2. Now I write another one step here. So we have 3 over 2 plus 1 divided by 5 over 2. Okay, plus this one we have negative 1 over 2, we plus 1. So we get 1 over 2 and divided by 1 over 2 plus C. Okay, right, 3 over 2 plus 1 and negative 1 over 2 plus 1. And we divide by the new value of the power. Now, what happened here? Divide, we can change to multiply, right? Change the divide to multiplication, and we flip the fraction. So it becomes 2 over 5, x to the power of 5 over 2. And this one, when we flip this, we have 2. So 2x to the power of 1 over 2 plus C. Okay, any questions here, student? Do you have any questions here?
No.
Okay, all right. Following questions here, all right, you are going to test yourself, see if you can actually perform the simple integration or not. All right, so I want you to complete this one. I will discuss with you one by one later.